This lesson is called Using Trig to Find Missing Values. Basically, what you're going to be given is you're going to be given a trig value, and you need to create a triangle and solve the triangle for the remaining trig values. So let's go ahead and just start with an example. Example 1, we have cosine of theta is 4 over 11. So I have SOHCAHTOA written on the screen there. If we're thinking of cosine, cosine is adjacent over hypotenuse. So what we're going to do is we're going to go to this triangle down here. I'm going to sketch in my right angle. And we're given the hypotenuse. So across from the right angle is the hypotenuse. So we know that this is 11. Then from your angle theta, I'm just going to use this angle down here as theta, but you could have chosen to use the top one. So across from theta, this is your opposite, which we don't have any information about. So we could just call that like x, because we don't know anything about opposite. All we know is the cosine of theta. So, but we do know the adjacent. Adjacent is 4. So this is the adjacent side. That is 4. So we know the hypotenuse and adjacent. We don't know the opposite. In order to find the opposite, we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. This is going to allow me to find the opposite side. So remember, in a right triangle, the hypotenuse is always your c when you're using the Pythagorean theorem. So I'm going to plug in 11 for c. So this will be c squared, which will be 11 squared. And then my a and my b doesn't matter. I could just choose x to be my a and then 4 to be my b. So x squared is just x squared. 4 squared is 16, and 11 squared is 121. Solve this for x now. Subtract 16 from both sides. So I get x squared equals 105. And then take the square root of both sides. Remember, square roots and squares cancel out. And for this problem, it's okay to leave your answer as just positive square root, because you're never going to have a case where you have a negative side length, because we don't use negative numbers to represent length. So this will be the square root of 105. So I'm just replacing x in my triangle with square root of 105. Now I can find the remaining trig functions. So I can find the sine of theta. I know this is going to be opposite over hypotenuse, O over h. So opposite is square root of 105. We just found that. And the hypotenuse, we were given that. It's 11. So square root of 105 over 11. The cosine of theta, we already have that one. So we're going to skip over that one, and then we'll go to the tangent of theta. Tangent is opposite over adjacent. So opposite side, remember, we just found that as square root of 105. Divided by the adjacent side is the side that we were given, so divided by 4. Now we'll do cosecant. Remember, cosecant and sine are related. So remember, cosecant is the reciprocal of sine, so this will be hypotenuse over opposite. So the hypotenuse is 11. And opposite is the square root of 105. However, you cannot leave the square root in the denominator. So you got to multiply by square root of 105 divided by itself. So remember, these square roots cancel off. And I'm left with 11 square root of 105 over 105. So that's my answer for that one. The secant of theta. Remember, secant of theta is related to cosine of theta. So cosine we know is adjacent over hypotenuse, so secant is hypotenuse over adjacent. So my hypotenuse is 11, and my adjacent is 4. So this will be 11 over 4. And then the last one is the cotangent. So cotangent of theta equals, and cotangent is the reciprocal of tangent. So this would be adjacent over opposite. So adjacent is 4, and opposite is square root of 105. Now, we have a square root in the denominator, so we're just going to multiply by square root of 105 divided by itself to get rid of the square root. So the square roots down there cancel. So I get 4 square root of 105 over 105. So there's my answer for that. So these are the 6 trig functions for example 1. Example number 2, we have the cotangent of, this letter is beta, is 7. But we want to think of 7 as a ratio because that's how we're going to answer these questions, is we need to know what is the ratio. So 7 as a fraction would be 7 over 1. So we're given cotangent. So we're just going to look at SOHCAHTOA, which I have written here in red. So remember, cotangent is related to tangent. It's the reciprocal of tangent. So this is not opposite over adjacent. This is adjacent over opposite because it's cotangent, so it's the reciprocal. So I'm going to label my triangle. Here's my right angle. Across from that's my hypotenuse. Then I'm going to sketch in my reference angle. So I'm just going to call this my reference angle theta down here. So I'm given, let's start with the opposite. So the side opposite theta, I know is 1. Because in the denominator is 1. The side adjacent to theta, the side that's touching theta, the A is 7, because in my fraction the numerator is 7. So we need to figure out what the hypotenuse is in order to finish finding the remaining trig functions. So use a squared plus b squared equals c squared. Now we're trying to find the hypotenuse. We don't know what that is, so we could just call that x squared. But we do know our opposite and our adjacent, so we could plug in, doesn't matter which one you call a and b, I'll call 1a and 7b. So 1 squared plus 7 squared equals x squared. 1 squared is 1, 7 squared is 49, and x squared is just x squared. I'll just simplify, so this is going to be 50 equals x squared. And now just take the square root of both sides to get rid of the square. So the square and the square root cancel. This gets you square root of 50 equals x. But we can reduce square root of 50 because that's divisible by 25. And 25 is a perfect square. So the square root of 25 is 5. And then we can't take the square root of 2. So my hypotenuse is 5 square root of 2. So I'm going to go ahead and erase the x there. And I'm going to write 5 square root of 2. So if you can reduce the radical, then you need to reduce the radical. So go ahead and pause the video if you need to finish the Pythagorean theorem part. Now what we're going to do is we're going to use a triangle that we have sketched here to find the remaining 5 trig functions. So first we'll start off with the sine of beta. Remember, sine is opposite over hypotenuse. So opposite is 1. And hypotenuse is 5 square root of 2. Now, when you have 5 square root of 2 in the denominator, all you're going to multiply by is the square root of 2. So you're not going to multiply by the 5. So these square roots cancel in the bottom, and I'm left with square root of 2 divided by 5 times 2, which is 10. This is square root of 2 divided by 10. The cosine of beta is adjacent over hypotenuse. So adjacent is 7. And the hypotenuse is 5 square root of 2. And again, remember, you need to multiply by the square root of 2 divided by itself, just like we did with sine, to get rid of the square root in the bottom. So this is going to be 7 square root of 2. So 7 times square root of 2. And then this is going to become 5 times 2 in the denominator. So simplifying, this is going to be 7 square root of 2 over 10. Then the tangent of beta. So tangent of beta equals, so tangent is opposite over adjacent. So opposite is 1 and adjacent is 7. Now we'll find the cosecant of beta. Cosecant of beta is the reciprocal of sine. So this would be hypotenuse over opposite. Hypotenuse is 5 square root of 2 and opposite is 1. So this would just be 5 square root of 2. secant of beta, this is the reciprocal of cosine. So this will be hypotenuse over adjacent. So hypotenuse is 5 square root of 2, and adjacent is 7. So this will be your answer for that one. So these are your 5 additional trig functions for example 2. Number 3, the cosecant of A is 11 over 3. So I have SOHCAHTOA written here for us. Remember, cosecant is related to sine. So it's the reciprocal of sine. So if sine is opposite over hypotenuse, then that means cosecant is hypotenuse over opposite. So it's h divided by o. So from here, what I want you to do is I want you to try to find the missing side in the triangle and then use that information to find the 5 additional trig functions. So pause the video and give it a try. When you unpause it, I'll have a solution here for you. So hopefully you gave number 3 a try. When you do this, your hypotenuse is 11, and then your a and your b doesn't matter which one you called a and b. So I had 3 squared plus x squared, so I had 9 plus x squared equals 121. I solved this for x, and I got x's square root of 112. 112 is divisible by 16. This would be 16 times 7. Square root of 16 is 4, and then you can't take the square root of 7. So the length of that adjacent side is 4 square root of 7. I now have my completed triangle, so I can find the other 5 trig values. So you can see those on your screen to the right there. I use SOHCAHTOA to help me with identify all of these. Remember, secant's the reciprocal of cosine, and cotangent's the reciprocal of tangent. So you should be able to complete the Math Excel assignment called Finding Missing Values Using Trig.